building a supercomputer and we're putting that power at the finger of everyone's fingertips. We believe that right now cloud is expensive and it's putting some barriers on the ability to innovate. It's a game for the rich. However, by marshaling all of the computers and devices and servers that are out there idle most of the time and serving that power up back to the people who can use it, we're pouring gasoline on an innovation fire, whether it's for AI, machine learning, mathematical physics, finance, blockchain, you name it.
All right, can you break that down for me a little bit? What does that mean, you're harnessing the power of all these idle systems?
So think of it as a network that can connect your computer, your phone, the smart fridge, even the Tesla in your parking lot, and all of the processors and all those machines. What are they doing right now? They're probably laying idle. Instead, they could be solving problems in terms of dark matter physics and computational chemistry and what have you. So our software that we're proudly developing here in Kingston, Ontario, connects all of those idle processors and makes it available to researchers and scientists and even innovators who want to build machine learning applications or what have you.
The closest analog that I can think of to this is that SETI system that's been happening for a while, right? Where people just let their PlayStation run overnight to discover extraterrestrial life. Is that a pretty good analog?
That's a perfect analog. We, however, have built this on web technology. So the old SETI at home model is built on old languages and old frameworks, whereas we've brought distributed compute to the browser and Node.js communities. And on top of that, we're also measuring the compute performed by different participants and able to financially incentivize them and remunerate them for the work they do on the network. So it becomes a sharing economy of computing power.
What does that financial incentive look like?
So right now, if you let a processor run for, let's say, a year, you'll make between $80 and $100 US.
So you're looking at you said a Christmas timeframe for the tech?
Between now and Christmas, we're launching our first hackathon with developers from across the world this weekend. And we're in the middle of conducting a major demonstration with Queen's University where we have, I think, 40 of their computers hooked up to the network and serving computational requirements for their researchers. This pilot is conducted jointly with Server Cloud Canada, and we're even showcasing interoperability with existing cloud. So it runs locally using the platform and can burst into arbitrary third-party compute providers.
You mentioned some of the testing partners. Do you have any research firms lined up for when this actually goes live?
We're working with the Canadian group behind the Square Kilometre Array coming online in the next few years. That's going to produce 13 terabytes per second of data that's going to need processing. We're working with a number of R&D firms and some startups doing machine vision, and we're excited to announce a $2.2 million project with the Government of Canada to process COVID-19 data to run predictive models to allow a safe return to work and to school.
Great. Dan, thank you so much.
Thank you very much.